welcome to True Project. In this video, we are going to explain about predicting memory compiler performance outputs using feed-forward neural networks. Introduction. Project addresses the importance of memory compilers in computerized process as memory consumption accounts for a significant amount of total power consumption. Poorly designed memory compilers can cause task execution to take longer time and consume more power, affecting power, performance, and area measurements, which is PPA measurements. To address this problem, project proposes employing deep learning feed-forward neural network to anticipate optimal memory for task execution. Memory optimization can minimize power consumption and speed up task performance. Objective. The goal of the project is to use deep learning feed-forward neural network to anticipate optimal memory in memory compilers. It tries to accomplish effective memory optimization for several classes including area, memory leakage, access time, and cycle time by training the algorithm on memory traces. User will be able to input task and memory details into the trained model to forecast whether memory is normal or not, which means it is optimized or not, indicating concerns such as excessive cycle time, access, or memory leakage. The ultimate goal is to improve memory compiler performance, reduce power consumption, and make task execution in computer systems faster and more efficient. These are the requirements needed for execution of the project. In first, hardware requirements, operating system of Windows, processor of i5 and above, RAM of 4 GB and above, hard disk of 20 GB and above are required. In software requirements, Python IDEL of 3.7 version is required. These are the design modules for execution of the project. First one is to upload PPA memory optimization dataset. Using this module, we will upload PPA dataset application and then read dataset and then display memory compiler parameters with importance codes related to class labels. Next one is to pre-process dataset. In this module, we will split dataset into train and test, which will feed forward will use 80% dataset for training and 20% dataset for testing. And this test data will be applied on train model and then calculate incorrect prediction error rate. Next one is train feed-forward neural network. A feed-forward neural network is a type of artificial neural network where information flows in one direction from input to output layer. It is used in project to predict optimized memory for executing tasks based on memory traces, enabling efficient memory allocation and reducing power consumption. In this module, we will input above trained data and test data to feed-forward algorithm to train a model, and then this model can be used to predict memory compiler. Next one is to train gradient boosting algorithm. Gradient boosting is an ensembling learning technique that combines weak learners to create a strong predictive model. It is used in the project for memory optimization, prediction, and performance comparison with feed-forward neural network. Gradient boosting is a powerful algorithm that can handle complex relationships in data and improve prediction accuracy. Using this module, we will train gradient boosting algorithm on same data and then compare its error rate with the feed-forward neural network and gradient boosting as an existing algorithm. Last module is algorithm error graph. Using this module, we will plot error rate comparison between proposed feed-forward neural network and existing gradient boosting algorithm. The lower the error rate, the better is the model, and proposed algorithm will be compared with the gradient boosting algorithm. For execution of the project, first open the code folder. This is the code folder and this is the dataset folder. This is the data. On this data, we will be training the model. And these are the model parameters, which are job ID, bank GB, HIP log 10, MBBS, and etc. Here, we have the class label as 1 and 0. 0 means memory is optimized. 1 means memory is not optimized. So close this data. And this is the model folder in which it contains the .pickle files and .h5 files, which has the algorithm information in it. This will be used in the runtime while execution. And this is the dataset link, and this is the main code file, and this is the run.bat file. Instead of executing the program in command line interface, we have created Windows batch file for execution. So double click on it for execution. This is the graphical user interface of the project. With this, we can interact with the program. And this is created by using Tkinter library in the Python. First, click on the button Upload PPA Memory Optimization Dataset. Select the data and click on Open. Here, On x-axis and y-axis, it represents the dataset columns names. In each box, we can see the column importance correlated to the class label, and the column with the high value in the box will be considered as important features, and these will be used to train the model. And here dataset is loaded. Now click on the button pre-process dataset. Here the total records found in the dataset are 1020, and data is split into train and test. In train we have 816 and in test we have 204. Now click on the button train feed forward neural network to train the algorithm. Here is the confusion matrix of the algorithm, which is feed forward neural network. Here is the predicted class and here is the true class. These are the true classification and these are the misclassifications. This is the error rate of feed forward neural network. Now click on the button train gradient boosting algorithm. Here is the confusion matrix of gradient boosting algorithm. And here is the error rate of gradient boosting algorithm. Now click on the button algorithm error graph. Here on x-axis we have the model names and on the y-axis we have the count of the error rate. Here among both the models, feed forward error rate is less than gradient boosting error rate. Exit the GUI. Conclusion. Deep learning feed-forward neural network is used to anticipate optimal memory in memory compilers. Memory compilers are essential in computerized operations because memory consumes almost 40% overall power consumption. Poorly designed memory compilers can cause task execution to take longer and consume more power, affecting power, performance and area, which is PPA measurements. The system can forecast optimum memory for executing tasks by training feed-forward algorithm on memory traces, lowering power consumption and enabling faster task execution. In terms of error rate, the new technique outperforms the existing gradient boosting algorithm, which is feed-forward neural network, resulting superior memory optimization predictions. The project shows how deep learning can improve memory compiler performance, resulting in more efficient and cost-effective computerized systems.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.